Alright, so anti-diffs and diffs. Differentiation. I'm so sick of this. So we know what a function is, right? F of x is the subject, and let's equal that to x squared. Super simple function. Sort of looks like that. But we need to figure out what the tangent line is, or what the equation of the tangent line is on that function. The tangent line is the line that intersects with the given function only once, sort of like this. Like that, I guess. But like a bit. Can I move it? That looks a bit better. It intersects only once and then keeps traveling, never hitting it again. That's a tangent line. And there's two ways you solve for this. Either they give you the point on the graph where it intersects, or they give you a point on the graph that is on the tangent line, and they make you solve. So let's figure out how to derive first. F dash of x equals 2x. But how do you know that? It's simple. It's a super simple formula that you need to make sure you remember, because you should be able to derive functions in like less than a second. Like it should be easy. F dash of x is equal to 2x because f of x equals x squared. And the reason that this is true is because to find f dash of x, you need to do n times x to the power of n minus 1, where n in this case is 2. N is just the coefficient of this. Or the power coefficient, I don't know. Which is why we just chuck n here. 2 times x, 2 minus 1, 2 times x to the power of 1, which is just equal to 2x. From there, we now have the derived function. This derived function is not the equation of the graph. It's just the equation of the gradient. Let's say, for example, we're given this 1, 1. And we're told to find the equation of the graph. We do this by first deriving, as we've done here, f dash x equals 2x. And now we have to substitute back in the value of the x, or 1, to solve for m, which is gradient. 2 times 1 is 2, which means gradient equals 2. Y equals 2x plus c. Or, better to write it like this, y minus y1 equals m x minus x1. M is 2. Just replace that with 2. And then we have this. But what are these values, you might be asking? You might be wondering, well, they're just 1, 1, 1. Because we know that they're on the tangent line. So we just sub them in. Y minus 1 equals 2x minus 1. Y minus 1 equals 2x minus 2. Y equals 2x minus 2 plus 1. Y equals 2x minus 1. And that's it. That is the equation of the tangent line to this graph, x squared, at 0.11. But they're not always going to give you these sort of easy equations. Sometimes they're going to give you points that are only on the tangent line and not on the graph. And you solve them by compromising for what you don't have, which is the intercept between the two. In most cases, we take the intercept as a. We take the x-axis, or the x coordinate as a, and the y coordinate as f of a, not f dash. Oh, wow. We take it as f of a because, as we know, to find the y coordinate, we just substitute the x coordinate, similar to how we find the y coordinate of the y-intercept. We just sub x equals 0 because at the y-intercept x equals 0. So doing this, we obviously get this, and if we're given the same equation, we can just rewrite the x-intercept as a squared. So from here, let's say we're given the point 6, 11. And given the point 6, 11, we need to solve for the tangent line again, right? And the way we do this is just the exact same. We derive it, giving us f dash x equals 2x, and then substitute in the value of the intersection coordinate, which in this case, instead of 1, is a. So it becomes 2a. F dash x equals 2a. That's right. Don't write that. M equals 2a. Then we rewrite the equation of this guy, 2a x minus x1, like that. And now we have to sub in these values again, like that, and like that, because we know that these points are on the graph. Y minus a squared equals 2ax minus a. So now we have y minus a squared equals 2ax minus 2a squared. Y equals 2ax minus 2a squared plus a squared. Y equals negative a squared plus 2ax. So now that we have this, we need to use this equation to solve for the a-axis, because if you just tell them that this is your gradient, it's rubbish. Because what is a? We have to figure out what a is, and we do that by using the other point that we're given. In this case, it's 6, 11 up here. So we substitute in 6, 11. 11 equals negative a squared plus 2a times 6. 11 equals negative a squared plus 12a. And now from here, it is just, what's it called? Quadratic equation. It's just a quadratic equation. I think I can solve it like this. If I just take the negative out, a squared minus 12a plus 11, a squared plus 11 minus 12a, a 11, 1, negative, a minus 11, a minus 1. So a equals 11 and 1. That means that in this equation, the gradient of this equation will equal 2 and 22. And now I gotta tell you that this point is actually already on this graph. And now you're probably thinking, wait, why are there two gradients now if there's only one intersection? Like, why is this line at this point have two gradients when this guy should already have one intersection here? Well, it's because further along the graph, if we keep doing it up and up and up and up, and off the page, and eventually you get to a point here that'll actually return back and intercept at this point. Nope. So there's not always one answer for one given point. If you're given the intersection point, there should only be one answer. Most of the time. I don't know. I don't know. But if you're given a point like this, that's only on the tangent line, you got to be careful because there might be more than one answer, like this time. And the way we figure this out, or the way we figure out the equation, is just, again, by substituting back in. Y minus y1 equals 2x minus x1. I haven't actually tried this. Y minus 11 equals 2x minus 12. 2x minus 12 plus 11, 2x minus 1, which is the exact same as this. And it's because they're on the same line. And now we just redo this same thing, except with 22, and we get y minus 11 equals 22x minus 12, 13, 132. And then 132, 11, 121. So y equals 22x minus 121. And these two graphs will both be tangent to this y equals x squared. But they will have different gradients because they intersect at the same point. Like this guy will look like that. This guy will look like that. Because this guy is like tangent at this point, you know? So it's super easy, super simple. But what about if we're trying to go backwards? Oops. Wow, that was horrible. Hang on. Alright. So now, what if we want to go backwards? You know? Because sometimes you got to go backwards. And that's what's called an anti-diff. And an anti-diff is turning f dash of x back into f of x. And a very important thing to note that I forgot to mention is that if it's... Oh, well. This is kind of obvious, I guess. F of x equals 2x. F dash of x will just equal 2. Because obviously 1, you move 1 over, 1 minus 1 equals 0. That's simple. But if we have f of x equals 2, or more commonly x squared plus 2, this will become just 2x as well. Because this is like x to the power of nothing. There's nothing here. It can't even be 0 because 0 would be 1. Oh, I know it is 0. What am I even thinking? It's x to the power of 0 because 2 times 1 is 2. So x to the power of 0, you move the x over, 2 times 0, no matter what happens, it's going to be 0, which means we just get rid of it. And that becomes a problem, not when you're doing the derivatives, because that's like super cool and easy, but when you're finding the antidiff, that becomes a problem, because the way you find an antidiff is using, again, this n value up here. I'll show you. F dash of x equals to 2x. The way you find the antidiff is doing 1 on n plus 1 times x to the power of n plus 1. That is the antidiff formula. And you always got to make sure you remember this 2. This 2 isn't affected by it. It sort of looks like this in a way. So don't forget about this guy. You might forget it. You'll look pretty stupid. In this case, x is 1. So it becomes 2. 1 on 1 plus 1 times x to the power of 1 plus 1. 2, 1 on 2, x to the power of 2. and then 2 times 1 on 2, which is just 2 on 2 x squared, which finally equals just x squared. And that's what we got before, right? F of x equals x squared, f dash of x equals 2x, and then if we anti-diff it, we just get the same thing. But we need to remember to add on an extra plus c at the very end, specifically for these values, because these values aren't accounted for in an anti-diff, because we can't, like, we don't see it, it's 0. There is no x value here to, I guess, add and subtract on, because it's just 0. So we need to add on this c value. And the way we solve for this c value is the same way we solve for the equations of gradients, right? Usually they'll give you a tangent line and tell you that it intercepts at 1, 1 again, and they'll just ask you to solve for c, and then you just plug it into the equation. Y equals 1 equals 1 plus c, c equals -1, y equals x squared minus 1. There's your answer. And that's easy. That's all you do. Sometimes they give you coordinates that are up here, not on the tangent line, but it doesn't matter. That's about everything for diffs and anti-diffs. You know, it's a hard, I guess, concept, but like bare bones, it's kind of simple. It's a lot of practice. The best thing to do is just questions, I guess. And yeah, just make sure you remember those 2 equations, and you gotta get snappy and quick, because they aren't gonna ask usually for those equations. Like, they're pretty easy to do usually. They're like, I don't think they're even 1 mark. They're like, yeah, they're probably not even part of the working out. I don't know, I'm not a teacher. But yeah, that's it.